Hello and welcome once again to our series of Jam lessons, treating the chemistry syllabus. Today we are going to be looking at oxidation and reduction. Popularly we call it redox oxidation. Your teacher, my name is Anjon Oluwafemi Excel. I hold a BS in chemistry from the University of Ibadan, and I also have a postgraduate diploma in education, science education, and analytical chemistry from the Redeemers University, Ede, in Osun State. So we are going to be looking at oxidation and reduction, and let's start with the learning objective for this particular topic. It is expected that by the end of this lesson, students should be able to, one, define oxidation and reduction in terms of electron transfer, addition, removal of oxygen and hydrogen, and changes in oxidation number. Secondly, it is expected that by the end of this lesson, should be able to identify oxidizing and reducing agents in chemical reactions. It's also expected that you should be able to assign oxidation numbers to elements and compounds and reactions using standard rules, which you're going to be looking at in the course of the lesson. It's also expected that you should be able to differentiate between redox and non-redox reaction using changes in oxidation state. And it's also expected that by the end of this lesson, you should be able to balance redox reaction in acidic and basic media using the half reaction and oxidation number method. It is also expected that you should be able to apply a UPAC naming based on oxidation state to write correct compound names and to demonstrate simple tests for identifying oxidizing and reducing agents in the laboratory. Okay, having said that, let's jump into the core of the lesson. And let's start off with a simple definition of what oxidation and reduction is, which we will refer to as redox. Now, an oxidation reduction reaction is a type of chemical reaction that involves a transfer of electrons between two species. Now, note this, which is very, very important, is a type of chemical reaction that involves what? A transfer of electrons between two species. That is what an oxidation reduction reaction is all about. An oxidation reduction reaction can also be referred to as any chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. So that's another definition for oxidation reduction reaction. So we've looked at two things now, two definitions. The first one tells us that it's a kind of chemical reaction in which involves the transfer of electrons between two species. We have also tried to explain or establish the fact that oxidation reduction reaction can also be referred to as a chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. Okay, so we have been able to establish that, which is very, very important. Now, redox reactions are common and vital to some of the basic function of life. We see redox reaction in a function of this. We see redox reaction playing out, so on and so forth like that. Also in respiration, these are vital life functions that we can see the redox reaction playing out. So it is not just isolated to, oh, in the laboratory, no. But in real life, we can also see oxidation reduction reaction, taking place or playing out as the case may be. So we need to look at, we've talked about redox reaction. We've tried to explain what it is. The next thing that we need to look at is the definition of oxidation and reduction itself. And we're going to be looking at the definition from different angles. Now, the first one is in terms of oxygen and hydrogen. So we want to define oxidation and reduction in terms of oxygen and hydrogen. Now, we can say that oxidation is the addition of oxygen to a substance or the removal of hydrogen. Oxidation, just like the name connotes, is the addition of oxygen to a substance And it can also be described as the removal of hydrogen from a substance. Okay. We can also define reduction based on these, as in terms of oxygen and nitrogen, that reduction is the removal of oxygen. So we are looking at the reverse, the opposite, of oxidation. So reduction is the removal of oxygen from a substance or the addition of hydrogen. So it's the removal of oxygen from a substance or the addition of hydrogen, and that is what reductress, the definition that we just gave. Now, when you look at this oxidation, now in terms of oxidation, addition of oxygen, when carbon react with oxygen, oxygen is added to carbon, it gives us carbon dioxide, and that is an oxidation process. The carbon become oxidized in the process of oxygen coming to meet up with it and reacting with it. So that's an oxidation, addition of oxygen. Now, in terms of reduction, and we're looking at it oxide, copper 2 oxide. When you have copper 2 oxide reacting with hydrogen, what happens is that the hydrogen will take up the oxygen, the copper becomes reduced, and then what you have there is that there's a removal of oxygen from copper. And when there's a removal, it's a reduction process that has been carried out. So these are examples to buttress oxidation in terms of addition of oxygen and reduction in terms of removal of oxygen. Now let's look at it again from the angle of removal of hydrogen. Now, oxidation in terms of the hydrogen. When hydrogen sulfide reacts with chlorine, you know, hydrogen is taken away from sulfur from sulfur in hydrogen sulfide, and then it is added to the chlorine. Chlorine being a highly electronegative element, is more than willing to take up the hydrogen. Now, in the process of doing that, what you have done is that you have reduced of hydrogen, and that is oxidation, because you said oxidation is the removal of hydrogen. Let's look at the next one, reduction in terms of addition of hydrogen. Now when you react nitrogen and hydrogen together to give us ammonia, what happens basically is that hydrogen adds on to nitrogen and then results in the formation of ammonia. That is addition of hydrogen, and that is a simple example of what? Of reduction. Okay. All right, let's move along now. Look at the next one. We want to define oxidation and reduction also in terms of oxidation and reduction in terms of electron transfer. Now, in terms of electron transfer, we say oxidation is the loss of electron. Oxidation is what? Is the loss of electrons. And then we say reduction is the gain of electron. Oxidation is the loss of electron. Reduction is the gain of electron. Now, we will always use this mnemonics, to remember how to define oxidation and reduction in terms of what's it called? Electron transfer. We use the mnemonic oil rig, oil rig. I remember when I was still in secondary school, it came in very, very handy and very, very helpful also. So when you can just remember the mnemonics oil rig, you know that oxidation is loss, reduction is gain. That is, oxidation is loss of electron, reduction is gain of electron. So that's a very, very oxidation and reduction in terms of electron transfer. When you just remember oil rig, and don't forget that we are blessed with that in Nigeria, in Africa as a whole. So remember oil rig, and then you say, oh, oxidation is loss, reduction is gain. All right. Fantastic. So if you get what I'm saying, just put it in the comment section that I get you, sir. Go ahead. All right. Fantastic. So we move along now, and then we look at example to buttress this. In terms of electron transfer, we can have this sodium, will lose an electron, and when it loses an electron, it gives us the Na plus E electron, that plus one electron, like what you can see there. So there's a loss of electron in that regard, that's oxidation. We can have chlorine too. Chlorine is gaining electron, is gaining two electron, and that connotes reduction. So that's those are good examples of oxidation and reduction in terms of electron transfer. Okay. All right now. So the The next thing we need to look at is the oxidation number or the oxidation state. Now, what are the rules that is stipulated for us to assign oxidation state? The very first thing is that oxidation state of an element corresponds to the number of electrons that an atom loses, gains, or appears to use when joining with other atoms in compounds. Now, in determining the oxidation state of an atom, there are 7 guidelines to follow. And we're going to be looking at those 7 guidelines one after the other. I will try as much as possible to explain what those guidelines are. So the first one is that oxidation state of an individual atom is 0. So when you have just an individual atom, the oxidation is just 0. It does not have any oxidation state whatsoever because it is an individual atom. It is not joined with any other atom whatsoever. So that's the first one. The second one is that the total oxidation state of an atom of all atoms in a neutral species is 0, and in an ion is equal to the ion charge. I'll give a classical example to explain this. When you have H2O, that is water, H2O. Now, the total oxidation state of all the atoms, that is when you had hydrogen plus oxygen, must be equal to 0, is equal to 0 because it is a neutral species. So it is equal to 0. So if you have KCl2, so the addition of all the atoms, potassium and chlorine that makes up KCl, will be their total oxidation should be equal to what? To 0. So you add them up, it will be equal to 0 because it is a neutral species. But when you have charged atom, let's take for instance maybe CO32 minus, that's carbonate ion. Now, a CO32 minus, the total oxidation number must be equal to the what? The overall charge. The overall charge in CO32 minus in this case is what? -2. That means when I had carbon and 3 atoms of oxygen together, it must be equal to -2. You understand? So if it is carrying a charge, the overall charge will determine the total oxidation state. If it's a neutral species, it will be what? Will be 0. Okay. All right. So let's move along now. Then the third rule or the third guideline is that group 1 metals have an oxidation state of +1, and group 2 metals have an oxidation state of what? Of +2. Is just a general rule. All group 1 elements from hydrogen to cesium, they have an oxidation of what? Of +1. Then when you go to group 2, you look at magnesium, you look at calcium and all of them like that, their oxidation state is what? Is always what? +2, which is a group 1 element. What you see happening is that you have a 281. The one out there is what determines the oxidation state. And one of the things about them is that they are more than willing to give up that one in order to be able to achieve the octet structure, which is a more stable structure. So the oxidation state of group 1 metals is what? Is +1, while the oxidation state of group 2 metals is always what? +2. Okay. Now the oxidation state of fluorine is -1 in compounds. Wherever you have fluorine, sorry, not fluorine, fluorine, fluorine. Whenever you have fluorine, combining always -1. You must bear this in mind as you go along. So please, let's take note of that. The fifth one says that, just a minute, please. The fifth one says that hydrogen generally has an oxidation state of +1 in compounds. Hydrogen generally has what? An oxidation state of +1 in compounds. Although there are exceptions to these, but fundamentally, hydrogen has a general oxidation state of +1 in compounds. Oxygen also generally has an oxidation state of -2 in compounds. So when you have oxygen in water, oxygen in carbon dioxide, oxygen in sulfur dioxide, and so on and so forth, wherever you have oxygen in compounds, they always exist in the -2 oxidation state. Okay. Also, in binary compounds, group 17 elements have an oxidation state of -1. That is the halogen family. Group 16 element as an oxidation of -2, and then group 15 element as the oxidation state of -3. So these are very, very important guidelines that we must be mindful on as we journey along in the world of chemistry. Okay, now the sum of the oxidation state is equal to 0 for neutral compounds and equal to the charge for polyatomic ion species. I've said this before when I was talking about guideline number 2. So the sum of the oxidation states is equal to 0 for neutral compounds, and it is equal to the charge for the polyatomic ion species. So we've touched on this before earlier. So we can move along now and look at assigning oxidation states. Assigning oxidation states. And the first one is that example that we are going to use to buttress this point is determine the oxidation state of each element in the following reaction. Determine the oxidation state of each element in the following reaction. Now, you have iron reacting with oxygen to give us Fe2O3. Now, we are told to determine the oxidation state of each element in the following reaction. So we want to look at the oxidation state of iron, of oxygen, and so on and so forth. Now, the second example is iron 2 plus. What is the oxidation state? Then you have silver reacting with H2S H2S, that's hydrogen sulfide, to give us Ag2S, that's silver sulfide plus hydrogen.